Hello everyone. In this video, we will learn to interconvert between the name of a chemical compound and its molecular formula. Various compounds that we are going to name can be broadly classified into two types. 1. Simple ionic compounds, and 2. Simple covalent compounds. We already learned earlier that ionic compound consists of a metal cation and a non-metal anion, while the covalent compounds consist of two non-metal atoms. The simple ionic compounds can be subclassified into three different types. Type 1 binary ionic compounds, Type 2 binary ionic compounds, and ionic compounds with polyatomic ions. First, we will learn to name Type 1 binary ionic compounds. First, let us understand what a binary compound means. Binary compounds are compounds consisting of only two types of elements. The binary ionic compounds contain a metal cation, always written first in the formula, followed by a non-metal anion. For example, NaCl consists of Na+, that is metal cation, and Cl-, that is non-metal anion. Similarly, Al2O3 consists of Al3+ and O2- ions. The following are the rules for naming a type 1 binary ionic compound. First, the cation is always named first, followed by the anion. Second, the name of the cation is same as the name of the element. Third, for the anion, take the first part of the element's name and add the suffix IDE. For example, if we have an anion of oxygen atom, the oxygen becomes oxide. If we have sulfur, it becomes sulfide. And if we have chlorine, it becomes chloride. The overall format of the name for a type 1 binary ionic compound will be metal followed by a non-metal plus IDE. We have seen two ionic compounds in the previous slide. Let us name these two compounds. NaCl consists of Na+ and Cl- ions. Na+ is named after its element's name, which is sodium. The Cl- is named by taking the first part of its element's name, which is CHLOR, and adding the suffix IDE. That is, the chlorine becomes chloride. Therefore, NaCl is sodium chloride. Similarly, Al2O3 consists of Al3+ cations and O2- anions. Al3+ is named as aluminum and O2- is named as oxide. Therefore, Al2O3 is aluminum oxide. The following are some common monoatomic cations and anions we use in this course. As we discussed earlier, the group 1 elements form a cation with 1+ charge. The group 2 elements form a cation with 2+ charge. And group 3 elements form 3+ charged cations. Similarly, group 7 elements form an anion with a -1 charge, and group 6 elements with 2- charge, and group 5 elements form an anion with 3- charge. We still haven't defined what type 1 ionic compound means. To define that, let us focus on the metal cations. We can classify all the metal cations present in the periodic table into two different types. One, the metals that can form only one type of cations, and two, the metals that can form more than one type of cations. Sodium is an example of metal that can form only one type of cation, that is Na+. And iron atom is an example of metal that can form more than one type of cation. Iron can form Fe2+ and Fe3+ cations. If we notice, there is a pattern here. Most of the main group metals, that is metals in the S block and P block, form only one type of cation, while most of the transition metals, that is the metals in the D block of the periodic table, form multiple types of ions. That being said, there are several exceptions to this. As you can see, silver, which is in the D block, can form only one type of cation, while lead, which is in the P block or group 4, can form two types of cations, which is Pb2+ and Pb4+. So, an ionic compound containing a metal that can form only one type of cation is classified as type 1 ionic compound, and the ionic compound containing a metal that can form multiple types of cations is classified as type 2. The examples that we discussed earlier, that is sodium chloride and aluminum oxide, are type 1 ionic compounds. Let us discuss a few more examples of type 1 binary ionic compounds. The question is, give the name for each formula or the formula for each of the following names. First, Ki. Ki consists of K+ cation and I- anion. K+ is named as potassium and I- is named as iodide with the suffix IDE. The name of Ki is potassium iodide. Similarly, the second compound is Rb2S. This consists of two Rb+ ions and S2- ions. Rb+ is named as rubidium and S2- is named as sulfide. The name of Rb2S is rubidium sulfide. The next example, we are given with the name of the chemical compound and we are supposed to write the molecular formula of the chemical compound. The example is aluminum bromide. Aluminum is in group 3 and always forms a cation with a 3+ charge. That is, the cation in aluminum bromide is Al3+. Bromine is in group 7 and always forms an anion with -1 charge. That is Br-1. So, to maintain the charge neutrality, aluminum bromide should contain 3 bromide ions for each Al3+ ion. Therefore, the molecular formula of aluminum bromide is AlBr3. We can use a method called as crisscross method to find out the molecular formula from the name. First, we write the cation with its charge and anion with its charge. And then we exchange the charges of cation and anion without the sign and turn them into subscripts. So if we start with Al3 plus and Br minus 1, if we do crisscross method, we end up getting AlBr3. Let us do one more example. The name of the compound given is magnesium oxide. Magnesium is in group 2, therefore it forms a cation with 2 plus charge. And oxygen is in group 6 and forms an anion with minus 2 charge. So we have Mg2 plus and O2 minus. Let us exchange these charges and make them as subscripts. The formula for magnesium oxide is Mg2O2. Now if we simplify this further, we get the ratio of magnesium and oxygen as 1:1. Therefore, the formula for magnesium oxide is MgO. Next, let us discuss how to name a type 2 binary ionic compound. As discussed earlier, a type 2 binary ionic compound contains a metal that forms multiple types of cations. As we discussed earlier, iron can form two different types of cations, Fe2 plus and Fe3 plus. Therefore, when it combines with Cl minus ions, it can form two different types of ionic compounds, FeCl2 and FeCl3. Let us name these two compounds with the same rules for the type 1 binary ionic compounds. The FeCl2 will be named as iron chloride and FeCl3 will also be named as iron chloride. We have two different compounds having same name. Now, two different compounds cannot have same name. If we do have the same name, we will not be able to distinguish between these two compounds based on their names. Therefore, to differentiate these two compounds, we represent the charge on the cation as a Roman numeral immediately after the name of cation in the name. Therefore, the format of the name will be metal, followed by the charge on the metal, followed by non-metal plus IDE. Let us follow this format and name the two compounds FeCl2 and FeCl3. First, FeCl2 has Fe2 plus and 2 Cl minus ions. So the format is iron followed by the charge on the iron, that is 2, followed by the nonmetal plus IDE, that is chloride. Therefore, FeCl2 is iron 2 chloride and FeCl3 is iron 3 chloride. Let us do one more example. Write the molecular formula of chromium 1 nitride. So we have chromium metal and nitrogen non-metal. The charge on the chromium is given as +1 and nitrogen belongs to 5th group. Therefore, it always forms -3 charge on nitrogen. Let us use the crisscross method and write the formula for chromium 1 nitride. The subscript for chromium will be 3 and the subscript for nitrogen will be 1. Therefore, the formula of chromium 1 nitride is Cr3n. So far, we have seen ionic compounds with monoatomic ions. However, there are ionic compounds consisting of polyatomic ions as well. A polyatomic ion consists of more than one atom. For example, a nitrate ion is written as NO3-. It is a combination of one atom of nitrogen and three atoms of oxygen with an overall charge of -1. The important thing to know about a polyatomic ion is when it is dissolved in water, it stays together as a single entity without breaking into individual atoms. That is, the nitrate ion in water stays as NO3- ion without further breaking down into nitrogen atom and three oxygen atoms. Some of the common polyatomic ions and their names are in the following tables. These names and formulas must be memorized. The rules for naming ionic compounds with polyatomic ions are same as type 1 and type 2 binary ionic compounds. Let us do a couple of examples in the next slide. Example: give the systematic name for the compound FeClO4 taken twice. We should know that the ClO4- is a polyatomic ion with -1 charge and its name is perchlorate. There are two perchlorate ions in the compound, each perchlorate ion with -1 charge. Therefore, the overall charge on the iron is +2. Iron can actually form more than one type of cations. Therefore, the charge on the iron must be represented in the name as a Roman numeral. The name, therefore, is iron 2 perchlorate. Let us do one more example. Write the molecular formula of potassium sulfate. Potassium belongs to group 1, therefore carries a +1 charge. Sulfate is a polyatomic ion with 2- charge, that is SO4 2-. We can do the crisscross method and exchange the charges on the individual ions as the subscripts. Therefore, the potassium sulfate is K2SO4. Note that the polyatomic ionic compounds are no longer binary compounds. That is, they have more than two types of atoms. Next, we will learn to name binary covalent compounds. Binary covalent compounds consist of two types of nonmetal atoms. Even though the covalent compounds do not contain any ions, their naming is similar to that of ionic compounds with few additional rules. 1. The first element in the formula is treated as cation and named using the full name of the element. The second element in the formula is treated as anion and named similar to an anion in the ionic compound. That is, we take the first part of the element's name and add the suffix IDE. 3. To denote the number of atoms present, we use prefixes. The following are the prefixes that we use. Mono represents 1 atom, di represents 2 atoms, tri represents 3, tetra means 4, penta is for 5, hexa is for 6, hepta is for 7, and octa is for 8. The format of the name for a binary covalent compound is the following: prefix followed by the first element, followed by the prefix for the second element followed by the second element plus IDE. For example, nitrogen can form several different types of oxides with the following formulas: N2O, NO, etc. Let us name these compounds. For N2O, the first element nitrogen is named like a cation, and the second element oxygen will be named like an anion with IDE as the suffix. We have two nitrogens, therefore it would be dinitrogen, and only one oxygen, and the prefix for one is mono. So it will become dinitrogen monooxide. Next, NO. We have one nitrogen, that is mononitrogen, followed by one oxygen, that is monoxide. If the number of atoms of the first element is 1, we usually avoid using the prefix mono. Therefore, the name becomes nitrogen monoxide. If the first element does not have any prefix, it means that there is only one atom of that element. Let us do one more example. CO2. We have one carbon, so we don't use the prefix mono, so it is just carbon, followed by two oxygens. The prefix for 2 is di, followed by oxide. So the name of CO2 is carbon dioxide.